Hi, and welcome to Lesson 8 of the DSK Coding series in Java. So, CPUs and tasks are generally, so far, have been single-threaded. Only one thing can be done at a time. We follow the logic, one thing, next thing, next thing, next thing. Now, why is multi-threading important? Well, what if we could do two tasks at the same time, because they don't really have anything to do with each other? Example, running our network server and our GUI at the same time, or having an output show up, counting numbers 1 to 1,000. Meanwhile, we can also be asking the user to be playing a game or something. They have nothing to do with each other and therefore can be inherently concurrent or parallel without a problem that they are somehow waiting for each other or something like that. Though we can do this with threads as well in order to speed certain things up depending how you implement it. For this specific use case, we're only dealing with completely separate cases where they have nothing to do with each other, no notifying and stuff like that. Alright, so a table of contents, first a process versus a thread, then the lifecycle of a thread, 3 or 4 common ways. I'm saying 4 because the one thing is iffy, you shouldn't use it. Implements, anonymous class and lambda, code examples, and then better ways of doing this. So what's a process and what's a thread? Well, a process is a consistent code execution block that has its own resources. They're not shared. Each one has its own individual piece. A thread, on the other hand, can run in the context of a process. What this means is it can execute sections of a process, subcode sections, and these threads can use shared memory. They can access each other's memory and then be able to run on that. As you can see here at the bottom right, I have 221 processes running and 2,990 threads. That does not mean all the threads are running right now. They could be paused, sleeping, whatever. And while Firefox here, as you can see, has multiple processes running. Right. Now, what is the life cycle of a thread? Well, the first thing you can do is you need to create a new thread. Then you have to have a runnable, which you can start. That will run, so you use a function called run. And while it's running, it'll do some stuff. You can make it sleep and wait or whatever, and then continue running. And then at the end of it, at the end of the program or the end of the thread, you end the execution instead. Then you can recall the thread, whatever you want to do. Same as a program, when it gets to the end of the code, it's done. Program closes and it ends. There are 3 or 4 common ways of implementing threads. One is extending a thread class. I don't recommend that you do this due to the fact that extending it means that you're overwriting the inherent behavior. So it's just better practice to always implement runnable. So you implement the runnable interface. The other way is you use an anonymous class, which implements runnable, or you use a lambda expression. Okay, we're going to actually use all of these except for the extending thread class. I don't recommend that you ever do it. There is no point for most cases. If you actually really need to do it and you're overwriting the thread behavior, well, that's quite advanced. You're probably doing it wrong. Now, implements. Implements is really easy with implementing runnable. All you do is write implements runnable. A pop-up will say, please implement all abstract methods. You do an @ override of the method run, and then whatever happens in here. So then you call this class, and it automatically implements or does whatever is in run. Okay. Now, an anonymous class, you do thread is equal to new thread, new runnable, and you do the same thing. This is exactly the same as you would do with your implements class. You would actually create a thread which creates or implements that class, so that new class. Lambda expression is exactly the same thing, it's just a lot shorter. As you can see, all you do here is 2 parentheses, lambda expression, and that will do your run. Code example, the next section, lovely. What is anything without code? Now, the first way we're going to do it is going to use implements. So we first need a new Java class, and we're going to make it implements runnable. We make it implements runnable. Now we're going to have an error because we're not implementing all abstract classes, so implement that. And all we're going to make this do is print out the numbers, for loop, int I is equal to 0, I is less than 100, and I plus plus. And then we're just going to print out I. That's all it's going to do. It's going to print out all the numbers from 0 to 99. Thread run equals new thread, and we're going to call it new implements runnable. and run.start. Okay, Let's see what happens. And as you can see, it wrote all the stuff. Now, can I do this multiple times? Can I make multiple threads that run in parallel? What about thread 1, 2? Now, what happens if I execute them both at the same time? Run 2 dot start. Sorry. Let's run that. Look here. 69, 50, 24, 14. Oh wait, look here, this jumps. So they're both running in parallel. Which one's faster? I don't know. One of them is. Now, are all threads the same? If I create one thread and I create another thread, will they each get to have the same priority? Absolutely not. Sometimes the one thread will get more priority, sometimes the other one will. You can overwrite this and give another thread more priority by using the priority constant, but we're not really implementing this. We're not doing anything with it. So which one's actually faster, which thread is faster? We don't know. You use something like synchronization if you want to make sure that the threads are both doing something at the right pace, that one waits for the other. But in our case, we're not really using this. This is a different topic. Now, one thing you can do, for example, is you can, instead of having to create an entire class each time, is we can just make a new thread as an anonymous function. New runnable. Now this will go red, and implement the abstract methods. Now for this, we want to, I don't know, print out what the current system time is. System.nanotime. Here we go, current time in milliseconds. That's all we're going to do. We're going to print that out. Okay. Now, what does that do? That's the current time in milliseconds, what my system's time is. So now I want to make it so this thread waits a second or 1,000 milliseconds before it prints out the time again, or just gives us the difference. So what you can use is called thread sleep. Now, of course, you need to make sure that there is a try and catch in case it is not able to make the thread sleep. And then we're just going to print out the difference because we want to know if it actually sleeps for 1,000 milliseconds. So I think it's a long or time is equal to system.current time in milliseconds. Print out that time. Let's print it out. And we're going to do system.time. Oh, sorry, current time. Minus that time. And then we're just going to run that. As you can see here, though, it took 1 millisecond for the system to come out of sleep and run this function. But it slept for about 1,000 milliseconds, which is probably about accurate enough for what we want to do if we want something to wait for a second. So if you want to make a countdown timer, 1 millisecond off will basically be wrong by a second every 1.5 minutes or so. What you can do, though, is you can make the thread sleep until the current system time actually hits a certain number if you want, rather. Again, there's different ways to do this. There are more accurate ways of doing this. It doesn't really matter. Now, the other way of doing this was in a lambda function. And NetBeans has a really nice built-in feature called use lambda expression. And that's it. That's the entire thread. So, what can we actually do with this? Well, we could actually make stuff run multiple threads or multiple things at the same time. We want to, as we had with the run 1 and run 2, we can then make two things, do simultaneous things that are independent of each other. We can also use synchronize in order to make things that are dependent on each other, but that's not part of this course here, and we won't be using that for now. Now, let's make something very more interesting. Which thread will win if I have two threads that all they do is they take a value and count down from that value, and which one will win? So let's give two of them 100 points, or let's start at 100 and make them count down to 0. Which one would win? I don't know yet, so let's make that. So, countdown. and while countdown is greater than 0, countdown minus minus. Of course, this countdown, you can't do it before that run. If I can actually type countdown, minus minus, and sound countdown. All right. Thread.name, thread.current thread dot get name, and we're going to create a constructor. Implement runnable string thread name. Sorry about that. Thread dot current thread dot set name to thread name. Okay, so then we can do that. So when we create it, we can then have a thread name. Over here, this should complain if we just make a thread. So this is the runnable one, which is equal to new thread, new implements runnable, and thread 1. You can call it whatever you like. And let's duplicate that downwards. Sorry. There we go. Thread 2. And then runnable 1 and runnable 2. So which one will win? Let's see. Oh, forgot to have the count. My bad. Countdown on thread. Value. And this will be countdown. Right. So let's just clear that. Run. Thread 1 lost. Because thread 0 was first. Now, why is it called thread 1 and thread 0? Well, that's when they were implemented. It seems that it disrespected our set name to thread name. Setting name to. And then we can print out what the actual thread name is. Sorry, thread dot current thread dot get name. All right, let's run that. So that's the name. And this seems to be running on a different thread because it gets executed before this finishes, it seems. All right. So that didn't work out very well. We'll see. Maybe I can fix it at one point. But it doesn't really matter since we've already used that unless we actually want to identify the threads. But as you can see here, in this case, thread 0 lost at 19 points. If we run it again, thread 0 was at 18 by the time thread 1 won. If we run it again, thread 1 lost, not thread 0. Thread 0 he has already counted down, finished. Here we go. So no thread will actually win each time you don't know. So be careful of that because you could have race conditions where one thread finishes before the other, and in specific circumstances other things could be running in the background that will make it so one thread lags behind the other. So you should make sure that whatever you're running is independent of the other, or use synchronization. Just look at it yourself to see what would work. Now, there are better ways of doing this, and that is future task and thread executor. Now, Why do I say this? Because this guy made a very nice argument. There is no time that you should ever use extend thread. That's over here. Always use runnable through composition. The future task constructor means that you can actually run it in a very nice fashion, whereby you actually create a pool or tasks and you say, I'm going to run them at that time. So you don't have to run them right now. You can say, system prepare to do it then. And then you can cache results, you can cache the threads, you can make sure that everything is ready to run at that time. So please use these instead if you don't want to use my way, but please never use extend thread. This is generally better or more modern, I would say. I don't know. But yeah, this may be a good way of doing it. If not, just keep going with runnables. There's no problem with that. Okay. I can't think of an actual task to do. You should use this with other things. Like if you're running your GUI and you don't want your GUI thread to freeze, throw your task onto another thread. Something like fetching stuff from your file or fetching stuff from your database, which we haven't done in this course, or the network section that will come next. We don't want to actually make the user wait for that connection because it can take up to a couple of seconds if the connection doesn't actually succeed. So then your GUI just freezes, your graphical user interface just freezes, and the user is just waiting, and the entire thing just grays out. You know how that looks like. Mac, you'd get the color wheel of death. Alright, and that's it. Goodbye.